The closest planet outside our solar system is 4.2 light-years away, and there is a serious, funded proposal to send a spacecraft there within a human lifetime. This is not a dream. It is an engineering project with real physics, real money behind it, and a destination that might already have the conditions for life. The planet is Proxima Centauri b, confirmed in 2016 by a team led by Guillaume Anglada Escudé using the HARPS spectrograph at the European Southern Observatory. It orbits Proxima Centauri, the closest star to our Sun, a red dwarf located 4.243 light-years away, part of the Alpha Centauri triple star system. Proxima b has a minimum mass of approximately 1.07 Earth masses, meaning it could be a rocky world. Its orbital period is 11.2 days, and it sits within the habitable zone of its star, the distance range where liquid water could theoretically exist on the surface. A second candidate planet, Proxima Centauri d, was reported in 2022 with a mass of approximately 0.26 Earth masses, orbiting even closer to the star. A previously reported third planet, Proxima c, remains debated. The Proxima system is scientifically extraordinary because of pure proximity. No other confirmed exoplanet is closer. But proximity is relative. 4.2 light-years is approximately 40 trillion kilometers. At the speed of the fastest spacecraft ever launched, NASA's Parker Solar Probe reaches speeds of around 690,000 kilometers per hour at perihelion. The journey to Proxima Centauri would take roughly 6,600 years. Conventional propulsion does not solve the interstellar problem. This is where Breakthrough Starshot comes in. Announced in 2016 by the Breakthrough Initiatives, funded with $100 million in seed money from investor Yuri Milner and supported by Stephen Hawking before his death, Breakthrough Starshot is a serious proposal to send gram-scale spacecraft, called Starships, to Proxima Centauri using laser propulsion. The concept involves an enormous ground-based laser array generating 100 gigawatts of focused power, directed at a light sail attached to each starship. The sail, made of ultra-thin reflective material, would be accelerated by the laser beam to approximately 20% of the speed of light. At 20% of the speed of light, the journey to Proxima Centauri would take approximately 20 years. A communication signal from the probe would take 4.2 years to return. So within roughly 25 years of launch, humanity could receive the first close-up data from another star system. The engineering challenges are real and significant. Building a laser array capable of 100 gigawatts of focused, coherent power on Earth does not yet exist. The light sail must be extraordinarily thin, on the order of a few hundred atoms thick, yet durable enough to survive acceleration forces. At 20% of light speed, interstellar dust and gas particles become dangerous high-energy projectiles. The Starship must carry functional cameras, communication hardware, and power systems in a package weighing roughly 1 gram. None of these individual problems are physically prohibited, but each requires engineering advances that have not yet been achieved. The habitability question for Proxima b is also unresolved. Proxima Centauri is a flare star. It regularly produces powerful ultraviolet and X-ray flares, far more intense than anything our Sun produces. Because Proxima b is in the habitable zone, it orbits very close to the star, close enough that the flare environment is a serious challenge for surface life. Tidal locking is also likely, meaning one side of the planet permanently faces the star and the other is in permanent darkness. Whether an atmosphere could redistribute heat, and whether it could survive the stellar radiation over billions of years, is actively studied and not yet answered. The James Webb Space Telescope cannot directly image Proxima b. The planet is too close to its star and too small. But future extremely large telescopes, including the Extremely Large Telescope currently under construction in Chile, may be able to attempt atmospheric characterization through direct imaging. The nearest planet outside our solar system exists. It may be rocky. It sits in the habitable zone. And there is a funded proposal to send something there. Follow for more on humanity's first real steps toward the stars. And tell me, would you support spending the resources required to actually launch a mission to Proxima Centauri, even if the results would only return decades from now?